Okay, so we've got a question here where we have to come up with the equation. Okay, so our equation has been y equals c times b to the x. Okay, where c is that initial value and the b is the change in the rate. Okay, so if the account currently has 8,000, that is my initial value. So that's what's going to go in for the C value. So we're going to have 8,000 out front. And then if it's growing at a rate of 0.25%, I have to add that to 1. Okay. So 0.25% is 0.025 as a decimal. And I have to add that with 1 to get 1.025 as the base of my exponent. So that's all going to be raised to the number of years that it's going to be. Now, when it says in part A, how much will it be worth in 6 years, you will just replace the 6 for that t value right there. Okay. Again, we do not want to multiply those first. We want to do the exponent. We want to do 1.025 all to the 6th power, getting this decimal right there, and then multiplying those by 8,000 to get a total of $9,277 after 6 years. Hopefully that wasn't too quick for you. This last one here, a person takes 200 milligrams of a drug and it depreciates. We lose it in the bloodstream by 20% each hour. So again, this is my initial value. And so that's why it's out in front. Again, our little equation is C times B to the X. So that initial goes in for the C value. And then we either add or subtract. So this says depreciates, depreciates by 20%. So we want to have to subtract 20% from 1. Okay, so 20% is 0.20, giving me 80% or 0.8 as my B value. Okay, so that's why we got this right here. I used D of T because it was the drug and then time. You could have just used Y. It's kind of being a try hard there with D of T, but whatever. So then we're curious, what's the concentration after 4 hours? So that's why I've got a 4 in wherever I see a T, I got to put in a 4. 0.8 to the 4th power gives you this decimal right there, 0.4096. And you would multiply that by 200 to get 81.92 milligrams in your bloodstream after 4 hours.